Alright, so today is the second day of day 2, so part 2 of day 2. We're doing questions 5 through 8, okay? So what we're going to talk about, we're going to do a few word problems, and then we'll do a couple other graphs to show you how we transform. So when we are transforming these, when I say that, I mean moving up, down, left, right. Okay, so we're trying to see what happens when we change our bases. We know that if they are higher bases, so a 5 is going to be steeper than a 1. Okay, so 1 raised to the x power is going to be flatter than a graph that would be 5 raised to the x power. Okay, so remember, just like in any word problem that you do, we need to read and pull out the important information because we know that they put a lot of information that we don't need. All right, so Miriam and Jessica are growing bacteria in a laboratory. Who cares? Miriam uses the growth function. Growth. Okay. F of t is equal to n raised to the 2t. Okay. While Jessica uses the function g of t is equal to n raised to the 4t. So n represents, okay, so we have one function, we have two functions. N represents the initial number of bacteria at time t. Miriam starts with 16 bacteria. So she starts with 16 bacteria. Okay, so we want to figure out how many bacteria should Jessica start with to achieve the same growth over time. All right, so what we're going to do, we have to use Miriam's first. Okay, so this is going to be strictly just algebra. All right, so f of t. So we are saying we're going to make t represent 1. Okay, so let's see. So n is 16 because they told us that. And then 2 times 1. Okay, so 16 squared is 256. Okay, so now what we want to do is we are going to ask ourselves, so now we have g of t. G of t. Equals to n 4t. All right, so again, I want this to be 1. I want to figure out n to the 4th power. When will that equal 256? Okay, so if this is 256, I want to know what n has to be equal to. All right, so what I'm going to do actually, because I know these are one of these answers is going to be the answer, right? So what I'm going to do is I'm going to say, okay, 32 to the 4th power. All right, there's no way that that equals 256. Okay, to the 4th power, no way that equals 256. But you can try it in your calculator if you don't believe me. Okay, 8 to the 4th power. That is 4,096. That doesn't count. Okay, and this one, if you haven't realized, is the correct answer. Okay. You could also, but we haven't talked about this, if you want to take the 4th root of 256, you can, but how about we leave that for Algebra 2? Okay, so again, I want to know which n, what should n be in order for Miriam and Jessica to be working at the same rate. All right. Number 6. So Madison and Julia are analyzing two exponential functions. Madison's equation is m of t is equal to n, so blurry. N raised to the 3t. And Julia's equation is j of t is equal to n raised to the 6t. So n represents the initial deposit, and t is time. So if Madison's initial deposit is $25, how much should Julia's account start with to have the same amount over time? So we're going to do the same exact thing, okay? So I'm going to do m of t is equal to n raised to the 3t. Let's make this be 1. Her initial deposit is 25, and then it's going to be raised to the 3 times 1, which is just 3. Okay, so, and again, if you don't know how to do this in your calculator, get out of here. Okay, so you're going to do 25, caret button, 3, enter, and there you go. Okay, there you go. Alright, so I get, and if you really don't remember how to do that, you could always do 25 times 25 times 25. That will get the job done. 6, 2, 5. Okay, so same thing. We're going to do j of t is equal to n raised to the 6t. So if this is 1, n to the 6 times 1. So I want to know what base raised to the 6th power is equal to this. Okay, so again, we're going to do all of these out until we find the answer. Okay, so this is actually 1,000,000. Way too high. 5 raised to the 6th power. Oop, winner, winner. Okay, so we have found our answer. All right, and again, it's simple as that. So I want to know, when will both of these be the same amount? Okay, what would my n value? What would they have to both put in order to have the same amount? Okay, so since her exponent, whose exponent? Julia's exponent is higher, that's why her base is lower. All right? Okay, a little more graphing. All right, so what I want you to notice with these, again, this is literally how you should put it into your calculator, okay? So put this, put what's in parentheses, put that in parentheses in your calculator. This will just ensure that you really get everything correct, okay? So once you put that into your calculator, you'll see you would get these numbers. So notice the difference with today. So these numbers are a little bit bigger than we've been using. So you might not really get a lot of perfect coordinates. So you need to do your best. A lot of the time when you get a question like this on the Regent, they're going to ask you to sketch it. But they still want you to have at least, you know, a couple points. Like you should have the y-intercept. And again, the y-intercept is that a value. So it's this number right here, okay? So a is the same thing as the y-intercept. Gosh. Sorry, I can't spell. I can do math. Can't spell. Intersect. Okay, so we want to know what happens when we double the coefficient. Again, the coefficient is a. Okay, so if we double a, we get 14 times 2 raised to the x power. So if you graph that, remember, we already did this. If this is bigger, then it's obviously going to get steeper faster. Okay, so let's put both of these into our graph. Again, you could put it onto your graph if you would like, but usually this is more of like a multiple choice question, and I really want you just to know how to answer these types of questions, okay, if you were asked. Alright, so I put both of these into my calculator. I did the original in y1 and this the one that is doubled in y2. Okay, so again, if I press graph, it's going to do my original one with the 7. Okay. And now my screen has a 10 by 10, but you still should see the change. Okay, so the one where 14 is my coefficient, it just gets steeper faster. Steeper faster. Okay. So hopefully by now you're making all of your connections, all right? So here we have another one. But we have our coefficient is a fraction this time. So when putting this into your calculator, you should get this. Again, you should be putting this into your calculator. A lot of you were not getting the, you weren't getting your tables right because you weren't plugging them into your calculator correctly. Because I know you're not doing this all by hand. So you're definitely using your calculator or you're just writing random numbers down. I'm not quite sure. But please take the extra second to put your parentheses in. Okay? And if you do not know how to put them into your calculator, you need to ask me. Okay? Alright, so what they want us to do now is they want us to take half. They want us to take half of this new graph, okay? So if I take half of the coefficient, half of 0.5, is just 0.25, okay? So what's going to happen if I take half is it's going to be the opposite of doubling it, so it's actually going to get flatter. So if you put both of those into your calculator, so again, I just put them both into my calculator, press graph. Here's the original one, 0.5. And here is the one that is in half. It is going to be flatter, okay, so less steep. Alright, so just to summarize what we've done for the past 2 days and how these graphs transform. Okay, so as the base, so first let's point out what all of these things are, okay. So if I have, I'm just going to rewrite it a little bit bigger over here. So, I want these different colors. Okay, so x is always going to be our exponent. You can wait till I'm done to pick everything. Okay, a is our coefficient. also known as our y-intercept. And lastly, b, which, if you haven't noticed already, is nicely standing for the base. Okay? All right, so as the base increases, the graph becomes steeper. As the base approaches 1, the graph flattens out. And when the exponent x is negated, the graph is reflected over the y-axis. And if the coefficient, so if, let's use our colors. Okay, so if the coefficient is negated, it's reflected over the x-axis. And again, by putting this into your calculator, I cannot stress enough how important it is for you guys to get better at using that calculator. Okay? Please, please, please.